Let's start. Looking at the numerical problem, sometimes we feel this is difficult, but when we write the given information, then we will feel the same thing very easy. I want to show you with the diagram also. Let's talk about this numerical problem a little detail. If two bodies are kept at a distance of 400 meters, let's say this first body, this second body, and they are at the distance of 400 meters. This is first information, that's why I want to write this information. Distance, which is denoted by d, is equal to 400 meters. The gravitational force between the bodies is 4.16875 into 10 to the power 4 Newton. Let's say this is F. Gravitational force is denoted by F and its value is given. Now this given, I want to write again. Gravitational force F is equal to 4.16875 into 10 to the power 4 Newton. Now reading the numerical problem, we get another information also. The mass of one body is 2 into 10 to the power 7 kilogram. This is first body and its mass is denoted by m1 and it is 2 into 10 to the power 7 kilogram. m1 is given. I want to write mass first. Find the mass of another body. Before that, here gravitational constant is given. That's why I want to write gravitational constant, which is denoted by capital G, 6.67 into 10 to the power minus 11 Newton meter square by kg square. These are the given of the numerical problem. Very easy. Just we have written given only. Now what the question? Question is mass of this second body. This second body. How much is the mass of second body, which can be denoted by m2? Mass of second body m2 equal to question mark. Here it is written. Normally these are the equations which we use to solve the numerical problem. Among these, which one we are using? Well, it depends. It depends upon the given information. All these 5 are present in this first equation. Look at this. M1, M2, D, G, F. M1, M2, D, G is given here and F. So, we are using first equation to solve the numerical problem. So, now we can write we have F equal to G, M1, M2 by D square. And we are writing values. In place of F, the value given here 4.16875 into 10 to the power 4 we have to write, and G 6.67 into 10 to the power minus 11, and then M1 is 2 into 10 to the power 7 kilogram, and M2 is the question, that's why we are writing just M2. In the process, it's not necessary to write units. Units can be written in given and at last in the answer. In denominator we have d square. D square means 400 square. 4.16875 into 10 to the power 4 into 400 square. Number interacts with number. That's why when we multiply 6.67 with 2, we will get 13.34. And remaining power of 10 to the power minus 11, here it is 7. And same base power can be added and subtracted according to their sign. Minus 11 plus 7 means minus 4. That's why 10 to the power minus 4. M2 remains same. In next step, M2 equal to, if M2 is separated in one of the side, then this number and power of 10 should be taken to another side. So in denominator I am writing this. This comes in denominator. Number interacts with number, that's why 4.16875 should be divided by 13.34. And when we divide, then we'll get 0.3125. And when this 10 to the power minus 4 of denominator goes up, then it becomes 10 to the power 4, and that 10 to the power 4 and this one 10 to the power 4 gives result 10 to the power 8. 4 plus 4, 8. And here we have 400 square. 400 square means 4 4s are 16, and there are 2 zeros, and if we go through square, then 16 having 4 zeros. Now next step, let's go to next step. M2 equal to, this number remains same. This is very big number, that's why we have to convert it into power of 10. Decimal point is at this place at the end, and if it has to be converted to power of 10, Then what we can do, we have to shift the decimal point from this position to this position. Means how many digit left hand side? 1, 2, 3, 4, 5 digit left hand side, and it comes between 1 and 6. If it is so, then we can write 1.6, but how many digit this decimal point is shifted to left hand side? 5 digit. That's why we have to multiply this 1.6 with 10 to the power 5. Then 1.6 into 10 to the power 5 equals to 160000. Now what we are doing, 1.6 is multiplied with 0.3125. When we multiply these two, then we'll get 0.5, and 10 to the power 8 remains same, and 10 to the power 5 also remains same. Normally point is taken after one digit, but here it is present just before the number. So this point can be shifted towards right hand side, one digit right hand side. We can shift this point to right hand side if we multiply this number with 10 to the power minus 1. If we had to shift this point to two-digit right hand side, then we had to multiply this number with 10 to the power minus 2. But we are shifting to one digit right hand side, that's why I am multiplying it with 10 to the power minus 1. Other remains same. Look at this, m2 equal to 5 into 10 to the power minus 1. Remaining powers are same. Now what happened at last? 10 to the power 8 plus 5 becomes 13, and 13 minus 1 becomes 10 to the power 12. Is the final answer 5 into 10 to the power 12. So I am writing this. Therefore m2 equal to 5 into 10 to the power 12. Since unit of mass is kilogram, that's why we have to write one sentence with the unit like this. Therefore mass of second body is 5 into 10 to the power 12. Mass of this second body is calculated. Okay, this way we can solve the numerical problem.